You've been using inheritance in the wrong way. So in this series of videos, we are understanding and applying the fundamentals of object-oriented programming by creating a replica of the famous game Asteroid. So this is the final project that we are going to complete in this series. It is a fully functional spaceship with a weapon that shoots bullets, a spawner for the asteroids, also a spawner for the saucers, and a complete game loop where the player will have some scores and it can explode and restart the play session. So in this video particularly, we are going to start from where we left in the previous video, where we study how we can understand object-oriented programming from the philosophy of language approach and the four tools that object-oriented programming offer to us: abstraction, encapsulation, polymorphism, and inheritance. So we ended up with this project right here, which is basically just a spaceship, the spaceship that we are going to use in the game, but it doesn't wrap its position. So in this video, we are going to end up with a component that allows us to wrap the position of any node 2D in Godot engine. It's a component that we can reuse across any node 2D, so basically across any project in Godot engine, that allows it to wrap the position of objects. And well, if we want to have access to all the files, to all the projects that we are using throughout this series, I created a product on my Ko-fi page, which is a project that is only available for the members of my channel, so the Ludonauts. It's $10 per month, and you are going to have access to this project right here, which already has the fully functional code for the final project and all the projects that we are going to use on every video, the start and the final projects of every video, so you can follow along as well. To become a Ludonaut, you can check my Ko-fi page and click on join. I'll put a link in the description. So that said, let's get started. So as I said in the previous video, inheritance is perhaps the trademark of object-oriented programming languages. But even though it is the trademark, people don't understand inheritance well, and even though they don't understand inheritance well, they overuse it, they abuse inheritance, creating very bad structured code bases. So the whole purpose of inheritance is to extend a class behavior while maintaining its contracts. So it's meant to add new features to an application, or in our case to the game, while also maintaining the contracts, the interface of the superclass, so that we don't break the code while we add these new features. So the whole idea of inheritance is that you should apply inheritance over two conditions. So you should meet both these conditions before you inherit a class. You will extend its code, so you will reuse the previous class code, and you are going to override some methods. You are going to override its behavior to extend it. So the whole idea is that if you want to just reuse the superclass code, you better just turn it into a component and reuse into a user class or something like this instead of a subclass, because this will allow you to create new contracts into the new user class while also reusing the code and the features of the behaviors of the component. And if you just want to maintain the contracts, to maintain the integrity of your application while overriding code, you will better be using an abstract class or an interface to override the methods that the interface provides to maintain the consistency across the code and not break the contracts that the abstract class established. So this is the whole idea. This is because inheritance will create some major problems, namely a hard coupling between the subclass and the superclass. The subclass will have to implement all the behaviors of the superclass while adding new behaviors as well, and maybe the subclass is not meant to apply and to implement all the behaviors from the superclass. So this is not an ideal scenario, and you will create a hard coupling between these two classes, which will prevent you to reuse them across projects because they will be typically very project specific. Using inheritance as well will make some rigid structures that you can't dynamically change in real time. So the idea is that by using components, you can create instances of these components and attach them to objects in real time, allowing you to adapt the behavior of an object in real time. Or if you want to, as we are going to see and as we are going to do in this video, you can also adapt a behavior of the behavior of an object in compile time as well, so using the Godot engine editor, or you can adapt the object behavior in runtime using GDScript, right? And well, let's see how we can do that in practice. So this is the project that we were left with by the end of the previous video, which is basically just a spaceship that can move around using physically simulated movement, but it doesn't wrap its position on the screen, which is something that we are going to implement right here, right now in this very video. So I'm going to start with by creating a new scene using just a simple node. A node that, since Godot engine already works by calling some methods in nodes, namely the red method, the red virtual method, the process virtual method, the physics process virtual method, the input method, method as well. Godot itself was meant to be used by extending nodes, so we should inherit these nodes in order to make our game work. Or we can implement a custom process tree that, well, this doesn't come into place in this video, but the whole idea is that Godot engine is meant to be used by extending nodes, adding behaviors to them. So note that we just met the two conditions. We are going to add new behaviors to a node and override its methods, namely its virtual methods. So let's get back to the Godot editor, and I'm going to name this component position wrapper, and I'm going to save it along with all the objects because it will wrap objects on the screen, right? So it makes sense to be in the objects folder. As I said, I typically organize my projects into like a pyramid of hierarchy. So we start with very small objects that do very small things, and we combine them together to create more complex objects until we end up with game screens, which is the highest level of this pyramid. So we start with objects that can become actors, that can become objects, and actors can be combined into areas, and multiple areas can be combined into levels, and levels and interface can be combined into screens. So this is my process of organizing my projects. I saved the position wrapper here. I'm going to attach a script to it, and essentially this script will ask for a node 2D, which we are going to call the rep p right here. Right, so with the rep p we can start to wrap its position, its global position. So the next thing that I'm going to do is to export a vector2, which will be the minimum screen position, or actually minimum position, because maybe we don't want to work with screen, right? So it's going to be vector2.0, and this will be the max allowed position, and this is going to be a vector2, which is my screen size. So actually the game viewport, right? So this is basically what we are going to do here. After that, we are going to override the physics method. Right here we just met the two conditions that we need to meet in order to extend a class or inherit a class. In this case, we are inheriting the node class, right? So in this method, we are going to basically say that the rep.globalPosition.x is going to be wrapped by the minimum position.x and the maximum position.y. And let's duplicate that and just change, actually max position.x, and here we are going to replace x by Why? And well, that's basically it, guys. We just created a component that will wrap objects positions. And just so you can understand how powerful favoring composition over inheritance is, I will make a brief challenge to you right here. So we are going to wrap the position of the asteroid as well, of the saucers as well, and maybe of bullets, right? So my challenge here is for you to comment below how would you do that using inheritance. Would you create a superclass that all these subclasses, so the asteroid, the spaceship, the saucer, and maybe the bullets will inherit from? How you are going to do that using inheritance? Because the way that we are going to do that using component is basically to attach this component to these objects, just like we are going to do with this player right here. So note that I don't, as I said in the previous video, I don't like to call the player a spaceship, to use the spaceship, to extend the spaceship as if the spaceship was a player. It is not. So the player has a spaceship, but in this case I will attach the position wrapper to the spaceship, because it's through the spaceship that the position wrapper will work. It doesn't make any sense to be anywhere else, so it will be a child of the spaceship, just so we can organize our thoughts here. As I always say, programming is a formalization of thoughts, so it's better to keep your thoughts organized, even though we are using a visually organized way to think here. So well, that's it. Let's just attach the spaceship right here, save it. So if we test this, well, let's go right here, and it is already working. So yeah, our position wrapper is already working. And well, just so you can see how easy this is to implement across other objects, I will create an asteroid scene right here. There we have it. This is our asteroid. It is an O2D that has a rigid body, that has a sprite 2D and a collision shape, so pretty simple. But what I want to show you is the interface of this asteroid. So the behavior of this asteroid is pretty simple. It starts by randomizing a direction and a velocity, and a spinning velocity as well. So this is the behavior of the asteroids. They can go wherever direction we randomize. But in the script, the way that I did that is by exporting. So remember that we can serialize some properties, right? Using the export keyword, we can save the property within the scene, and Godot will override whatever value that we apply here with the serialized value, which is the value that we can assign through the inspector. So I added two, one for the minimum and one for the maximum linear acceleration, for the angular acceleration as well. But the movement direction, the spin direction, and the actual linear acceleration and angular acceleration are what we call private member variables. So what private means is that outside classes are not supposed to have access to these properties. They are not supposed to mess around with the value of these properties. This is meant to be accessed and changed and mutate. Remember mutations from the previous video? This is meant to be mutated by the class itself and not by any other class. So this is what this private property means. And remember that we are, as I always say, programming is about expressing and formalizing your thoughts. So the way that programmers agreed that a property, a member variable, is a private member variable is by prepending an underscore. So this is another confirmation of what I say about approaching programming from a philosophy of language approach instead of approaching it from a mathematic approach or from like computing or electric engineering approach. By understanding that we are using language here, we can create better code, because this right here is meant to communicate to everyone that is going to use the asteroid class, even to me, to myself in the future, that I'm not supposed to mess around to mutate these properties from outside this class. But well, you can see that the procedure that creates the linear acceleration is a randomization between the minimum and the maximum linear acceleration, right? So this is what how this linear acceleration will be created and will be used right here using the movement direction as well. So the movement direction will also be randomized as well, so that the asteroid can go wherever direction we get from a random method. And as I always say, we should give name to the procedures that we create. And by giving the name of the procedure of randomizing the linear acceleration, I created the method randomized movement, which became the interface for other classes to actually mutate, to actually create this movement. And what this procedure does is that it will basically do all this, changing the movement direction, x and y properties. So it will be random, and then it will normalize, and then it will change, and etc, etc. But all of this is not meant to be known by outside classes. So it basically encapsulated these procedures, providing a better interface to the outside classes so that they don't have to do all of these themselves, running the risk of running to creating some errors in the code. And I did that by simply giving a name to the procedure of randomizing the movement of this asteroid. So the same happens with the randomized spin, but the randomized spin, you can see that I have a recursion right here because I don't want it to be 0. This will mean that the asteroid will never spin. I don't want it to never spin. I want it to either spin to the left or to the right. So if it managed to find if you manage to randomize 0, I want you to try again. But this is it. I don't want any other classes to try all these procedures themselves. So I created this interface so then they can use these interfaces instead, and will maintain the behavior of this class intact if they want to implement this behavior. But well, that said, let's attach the position wrapper component right here to the rigid body. Assign rigid body. I'm going to save, and let's see if its position is going to wrap. And as you can see, it perfectly wraps the position of the asteroid. And let's see if we can test this out together with the player. So I'm going to create a level. Remember that I like to make to create more complex scenarios, to create more complex scenes in order of simpler components that will interact together. So when I want objects and actors to interact together, or even objects and other objects, or actors and other actors, I create a level, or sometimes I create an area. Is more common to create an area, but in this case I'm going to create a level. A level typically has some areas inside of it, but in this case I just want to use the player, and I'm going to create a container for asteroids, and I'm going to add the asteroid right here. So if we test the level scene, yeah, so let's add some more asteroids, and I'm going to put the player at the center of the screen, right? So player transform divided by 2, and that's it. Let's test this again. So the asteroids are wrapping, the player is wrapping, and everything is working. And well, if you need help with your journey in game development, you can acquire my Mission Celine, which is a monthly game development mentorship, which is planned to be a 6 months long journey that will meet weekly to help you design, develop, and launch your first game so you can start earning money with your passion, just like Victor did. So Victor is one of my students. We developed Ornament Tower together. Ornament Tower is the product of this mentorship with Victor. It's a pretty cool game. It's like a Sokoban game where you have some puzzles that should drag some crates around. And after that, Victor created one of the coolest assets pack that I saw in the Godot ecosphere, which is a asset pack that is basically an implementation of many of the Mega Man X behaviors. So you can see that these are the behaviors that Victor added to this template right here. And recently, Victor launched this asset pack, which is a state machine. So Victor became a very competent programmer after the mentorship. This is of course not only something that is just because of the mentorship. Victor is a very competent person. He used to be a very good artist. So when he reached me out to acquire the mentorship, he wanted to learn how to code in Godot engine, and this is how I helped him. But he has a lot of great ideas. He is a very good entrepreneur as well. So if you want to acquire the Mission Selene mentorship, I'll put the link in the description. If you want to test out Victor's project as well, I'll put the link in the description. If you like this video, don't forget to leave a thumbs up, to subscribe to the channel to get more about game design, game development, and what I call game thinking, which is a type of content that I want to create in the future. But for this video, that's it. Thank you so much for watching. Keep developing, and until the next time. Bye bye.